Okay, so we're on to question 5, which is a binomial distribution question. So we're going to start by just writing down the distribution. So x equals number of floored pins. And we know that x is distributed binomially 20, 0.1. So for part A1, we're trying to find the probability that x equals 3. So we can do that directly on the calculator. So we're going to go to 7 for distributions. We're binomial probability distribution because it's equals. So option 4. We're going to do that just as a variable because we've only got one value. X equals 3. N equals 20. P is 0.1. And it gives us an answer of 0.190. For part 2, it asks us for at least 2 drawing pins with floors, so it's the probability that x is greater than or equal to 2, so that means it's 2, 3, 4 all the way up to 20. So the converse of that is less than or equal to 1, so it's going to be 1 minus the probability that x is less than or equal to 1, remembering that we're always looking at the left hand side of the distributions. So we're going to go back to our menu, 7. Here we're looking at cumulative distribution because it's less than or equal to, so it's binomial CD. Again, variable. Here we're going to just change our x to 1. It remembers the other parameters of the binomial distribution. And it gives me an answer of 0.392. So it's 1 take away 0.392. Gives me an answer of 0.608. Now for part B, we've got a nested binomial distribution, which is increasingly common in the new spec of A-level questions. So here we're going to need to define a new variable. So for part B, we're going to say y equals number of boxes with more than 2 volty pins, with at least 2 faulty pins. And here we're told that y is distributed binomially, the number is 3, and the probability is 0.608 is what we worked out in the last question. Here it's asking that the probability that y is greater than or equal to 1, which is 1 minus the probability that y equals, you can put less than or equals to 0. Okay, so we're going to use our calculator to do that. Again, going back to the menu, 7. I'm going to use my binomial PD, which is option 4. I'm going to use my list. Oh. Please bear with me. There we go, I'm going to use my variable. So here I know that x equals 0, n equals 3, probability is 0.608. And the answer is 1 minus 0.060. Which gives me 0.94. So part C asks us to conduct a hypothesis test. So under my hypothesis test, under the null hypothesis, the probability is equal to 0.1. Under the alternative hypothesis, the probability is greater than 0.1. And we know that x is distributed binomially 20 p. Notice I don't put in my value of p here because I'm testing that value of p. So, under h0, x would be distributed binomially 20, 0.1, and I'm trying to find the probability that x is at least as extreme a value as what we've seen. It's always looking at least as extreme a value, so the probability that x is greater than or equal to 5, which is 1 minus the probability that x is less than or equal to 4. So let's go back on our calculator to our binomial cumulative distribution. So we're going back to binomial CD. We're looking at a variable, and here I've got x is equal to 4, n equals 20, p is 0.1, and it gives me an answer of 0.957. 1 minus 0.957. 1 minus 0.957 gives me 0.043. The question asked me to test at the 5% significance level whether or not whether or not the probability was higher than 0.1. So here, this is 4.3%, so it's less likely to have happened than that 5%, which is my significance level. So I'm going to write up here 4.3% is less than 5%, so that means that we're going to reject that null hypothesis. So implies there is sufficient evidence that the proportion of flaws is greater than 10%.